right, this is more of a review, kind of going over what we've gone through so far and kind of practicing some of those proofs. Okay, so if we look at number 1, they're asking us if we can prove whether or not they are congruent by side, 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 or side, angle, side. Okay, so in number 1, what do I have? I have side, angle, side. Yep, because it goes side, angle, side here, and on this side, side, angle, side here. So we can go side, angle, side, and then they want a congruent statement. Okay, so they want us to say triangle, what, YQT is congruent to what? What goes with Y? K. What goes with Q? C, P. Yep, so some of them you just have to look at a little bit more carefully. Okay, number 2, what could I say? Okay, because we can say that that middle one is also congruent to it. So therefore we have side, 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 because we have all 3 sides congruent. So triangle ABC is going to be congruent to triangle, what? C, D, A, yeah. Be careful with the order that you go in. We're going to skip number 3 right now because I don't think we're ready for overlapping triangles. We'll talk about those actually more towards the end of the chapter. Okay, how about number 4? I'm hearing a few side angle sides. Okay, remember with side angle side that that angle has to be between my 2 congruent sides. Okay, is this angle that we have congruent in between my 2 congruent sides? No. So can I say that? No. So in this one we got to go not enough information. Okay, how about number 5? Who? What? I heard it. Side, side, side. Okay, anytime, guys, that I have a shared side like this, and I'm putting it into a proof, what's my reasoning for it? If I were in my proof, if I said EF is congruent to EF, reflexive property, yes. Okay, so triangle, what should we go? CEF is congruent to triangle, what goes with? DEF, yep. What's that? Not necessarily. They can still be side, side, side because I still might have all 3 sides congruent. Yes. Yep. Okay, side angle side is if it goes side and then an angle and then a side. If we look at number 6, okay, we've got 2 sides, right? Okay, now, what other piece of information do I have? I have vertical angles, okay. That doesn't do us any good though, right? Well, yeah, we've got that they're congruent. What else? No, we don't have MA and AJ are congruent. Nothing that says that. What are those like triangle arrow things on DJ and ME? That means that they're parallel. Okay, if you look at your gold sheet, if you have parallel lines, what are you supposed to look for? Alternate interior angles. So my alternate interior angles are going to be here and here, right? And actually here and here, but those don't do us any good. So now that I have these angles, now I have side, angle, side, right? And side, angle, side. Does that make sense how we came to that conclusion? Okay, so triangle DJA is congruent to triangle What does D go with? E. J goes with M. And A goes with A. Okay, number 7. Do I have all 3 sides? I don't have all 3 sides. Do I have the included angle? Do I have the angle that's in between my 2 congruent sides? Nope. So therefore, not enough info. Okay? Never will it work to go in the order of angle, side, side. Okay? You cannot have angle, side, side in math class. Just saying. Doesn't work. Okay? You can always think that. Okay? The one thing that doesn't work is the one that spells a swear word. Crazy, huh? Okay, this one. What can I say over here? Side angle side, because I have vertical angles, yep. So side angle side, triangle ABC is congruent to triangle, what goes with A? EDC, yep, good. All right, so let's practice some proofs. The moment we have all been waiting for. All right, I will give you a clue. In today's assignment, when you get the ones that are in this font, each given is a different step. Okay, so let's start, according to your gold sheet, what do you always start with? Givens. So AB is congruent to CD, given. AB is parallel to CD, given. D is the midpoint of BE, given. Okay? What does it say? What else are you supposed to do in step number 1 on your gold sheet? No, in number 1. Mark your diagram. AB is congruent to CD. Okay, so now, according to this guy, AB is parallel to CD. Okay, so according to your gold sheet, if you have parallel lines, what am I looking for? Alternate interior angles or corresponding. In this case, we don't have alternate interior angles. We have corresponding. Angle B. Well, it's not angle D. You got to be careful with that. We can say angle B because there's nothing else that goes out there. Or we can say angle ABD is congruent to angle CDE. Now why? Because what kind of angles are they? Corresponding angles. Okay, so that was based off of this guy, right? So now we have another given that might give us some good information. It says D is the midpoint of BE. So if D is the midpoint of BE, what can we conclude? Thank you. BD is congruent to DE. BD is congruent to DE. Does anybody know why? What would we put for our reason there? Because it's based off of this. It's going to be definition of a midpoint. Because that's what a midpoint states. If I have a midpoint of a line, it's going to make 2 congruent lines. That's my definition. Okay, so now, do I have congruent triangles? Based off of what? SAS. So that's going to be my reason. SAS, these are going to be my congruent triangles. Triangle ABD is congruent to triangle CDE. And your reasoning, okay, I'm going to tell you right now, your reasoning is this for this assignment today is either going to be SSS or SAS. Okay, that should always be your last step in these. No, because we're actually doing proofs. Okay, so there has to be enough information in order for us to prove it. Okay, so flip your page. Only 4 steps to this one, so this one should be a little quicker. What are we supposed to start with? Givens. Km is congruent to Nm. Lk is congruent to Ln. Both given. Mark your diagram. Km, Mn, Kl, and Ln. What else can I say? Lm is congruent to Lm. Why? Reflexive, yes. Boom, do I have enough information to say SSS? And we can put that prove statement right in there. Triangle LKM is congruent to triangle LNM. Notice how our last step, our reason is never prove. Okay, some of you still have the habit of putting prove for our reason right here. Not possible. Woo! All right. Write our givens. AD is congruent to AB. Ooh, that's already marked for us. Good. Okay, then it says AC bisects. What the heck does bisect mean? Split something into 2 equal parts, right? Right? Okay, so AC bisects DAB. So AC bisects this angle DAB. So what does that mean? It means that angle. No, we're talking angles, guys, because it bisects an angle. No, AC, this line, bisects this angle. So this angle right here gets bisected. So what are my 2 congruent angles based off of that? DAC, angle DAC is congruent to BAC, yep. Because this is my big angle right here. And it gets cut in half by that. Why? This one was given. What would this be? Definition of an angle bisector. Because that line is an angle bisector. It bisects the angle into 2 parts. Okay, so now I have, so we just said that that's congruent to that. What else can I say? Look at your picture. AC is congruent to AC. Always, always, always look for that shared side. Reflexive. You will use reflexive a lot. So this is what? SAS. We have a side, then an angle, and then a side. So triangle ADC is congruent to triangle ABC. Okay, one more. We have JM is congruent to NM. JM is congruent to MN. Given, we have L is the midpoint of JN. Given. So, based off of L is the midpoint of JN, what can we say? Good. JL is congruent to LN. Why? There you go. Good. Definition of a midpoint. What else can we say? Yeah, now we're catching on. LM is congruent to LM by reflexive. Why are these triangles congruent? SSS. Triangle JLM is congruent to triangle NLM.